All right, so we are Group 2. I'm Joe, I'm joined by Elijah and John, and this is our passenger project. So for our segment of interest, we chose the southern portion of First Drive. That is the section all the way from North Avenue to the CRC. And we picked this because we felt like it was not too big to analyze, but also it gave us a number of distinct kind of road varieties. Now for our index of multimodal infrastructure. General overview, there are a ton of modes serviced by this section of First Drive. Everything you're going to see on a college campus, that being automobiles, buses, pedestrians, cycling, micromobility. It is unique on campus in that it sees freight transit. It also has on-demand and Class M vehicles. So with this, there comes a variety of different facilities. ADA accessibility, loading zones, crosswalks, bike parking, bus stops, the works. So for our pedestrian assets, there are a number of crosswalks across this section of street. It is also a part of the Pi Mile, which is a popular route for joggers and runners. And then it does connect two of the large major attractions on campus, so there is a number of pedestrian traffic, or volume of pedestrian traffic in this area. For bikes, we have conventional bike lanes from North Ave all the way to the Student Center along the entirety of this stretch of road. You're also going to see plenty of bike parking in front of buildings in this area. Now, for our kind of performance metrics, we have our BLOS and BLTS. For the BLTS, we have the conventional bike lanes chart. And as you can see, there is one through lane per direction for the entirety of this stretch of road. The bike lanes are less than 6 feet. They're about 4 feet wide. And then the prevailing speed, which is the general speed limit for the street, is between 33.5 and 38.5. The speed limit for the road is generally 35 miles per hour, which gives us a LTS level of 2, which is generally pretty good. It's kind of just above average. For the BLOS, using a number of kind of assumptions and the equation seen above, we get a 5.56, which corresponds to a F grade. You asked us in assignment 1 what we felt better represented the street. We do not feel that this street is a F in relation to bikes. So we do feel that the BLTS, LTS level 2, is a better representation of the street service. Micromobility, wherever you see bikes, especially in an urban city, you're going to get micromobility. Birds and Lime scooters are found across the entirety of this piece of First Drive. And then obviously vehicular traffic. There is one through lane, generally low speeds and low traffic volume. Curbside parking is found along the entirety of this stretch of road. And then you also have parking zones for Class M vehicles.
Okay, so we also measured ADA compliance for the street segment using the 2010 ADA standards for accessible design from the DOJ. These kind of include a few numerical things like ramps and ramp slopes not being allowed to be more than 8%, no gaps or pavement disjoints above a quarter inch, and no cracks or debris. This road segment generally follows those rules very, very closely and well, except near construction where torn out pavement areas create disjoints larger than 0.25 inches. Which obviously makes the road segment basically intraversable for wheelchair users, but it's also particularly dangerous to vision impaired people, but also just normal people with no accessibility requirements, because you can trip and it's not great. And all the construction zones also often close roads, which reduces the width to 0 feet, which is obviously not acceptable. There's also buses. There's several bus stops along this route. The major single routes are the blue, red, and gold, all go through this. It also includes the transit hub where they kind of tend to coalesce. We also have the 2 major freight loading zones on this area, including at the exhibition hall, and the major one at the Student Center, which services campus mail. So we decided to collect data volumes over 4 different 15-minute sections for vehicles, pedestrian, bike, scooter, and bus, to basically A, check to see how accurate our survey data was going to be, and B, to kind of also get some general ideas for BLS calculations and some other metrics. So these are all the data sessions we conducted. This was kind of the one our peak hour period from 5:30 to 5:45. So to break them down, we had 421 total entries, 41.3% were pedestrian, 39.7% were vehicle, 6.4% were scooter, 5.2% were bike, 3.8% were bus, and 3.6% were other, usually scooter, one-wheeler, golf cart. The HDV percentage, which we used in BLS, was calculated using this at 10.4%. We also calculated the bus headway for Stinger routes. Overall, when you combine the blue, red, and gold buses going in one direction, you have a estimated headway waiting time of 5.625 minutes, which is about what GT shoots for. Also, there's more traffic going towards the CRC than away, except for right outside the CRC, likely because Regents Drive diverts a lot of traffic in that area.
And now for the second section of the data collection portion, the multimodal survey. This survey was designed in Google Forms and accessed using a QR code, and the questions included how often respondents use First Drive, the main modes of travel they use when they're using First Drive, and the purpose of their travel on First Drive. We also included a section for problems that the respondents encountered on the First Drive and any desired changes or improvements they would like to see. The audience for this survey was mainly tech students, with a large portion being CRC employees and a civil engineering research group. As for the results, we found that the majority of people are using First Drive rarely, and when using this section of First Drive, the majority of people are walking, and the second most frequent mode used was driving. Some of the most common destinations we saw were the CRC Student Center and classes. Some issues we saw in the survey were construction closures and unsafe bike lanes, and some desired changes included filling the potholes and changing the light patterns on Regents Drive. And next, for our design improvement, we decided to utilize a rectangular rapid flashing beacon, which would be activated by pedestrians to warn drivers of pedestrians that are about to cross. We also included, based on the survey results, recommendations of filling the potholes along First Drive and changing the light timing on Regents. For the impact of this improvement, it has been proven by the FHWA, the Federal Highway Administration, that RFBs can decrease pedestrian crashes by up to 47%. And according to the same administration, 11,000 injuries occur annually in incidents involving unsafe pavement edges, in which the survey indicated that multiple people were complaining about tripping over uneven pavement and potholes. Here are our references, and thank you for watching.
Woo!